Hello all again. I can't book this equipment again for you, and since you're away, I'm just going to show a video which you're going to have to watch in your own time. This is called the Rubens tube, and it's like a very big Bunsen burner. It's connected to the normal gas tap. There's lots of tiny holes in this long tube here. If I turn the gas on, I have a match which is actually burning. I should be able to set the gas on fire coming out of those small holes. There we go, seems to work. So, at the moment, it's got lots of flames, it's like a big long Bunsen, fair enough. The thing about the Rubens tube though, it sends sound from a speaker in one end through the tube through which the gas is passing. It then hits a solid end at the far end, a big flat piece of wood, and so the sound will then reflect off that end and head back in this direction. So the sound coming from the speaker at this end, this blue thing, will interact with its own reflected sound coming from the far end, and if you play exactly the right frequency into the Rubens tube, you can produce positions where the sound waves are cancelling each other out the whole time, and so the air stays still, and you can get positions where the sound waves are adding to each other the whole time, constructive interference areas where the air is shaking around a lot. Now, the flame is here because we can see where these areas are. The nodes, which is where there is destructive interference, and the antinodes are where there is constructive interference. Because where the average gas pressure is higher, the flame comes up further. So I'll show you that. For certain frequencies, it makes not much difference, but at other frequencies, you can find these standing waves. So here we go. There is a higher average gas pressure here, and here, and a lower average gas pressure here and at either end of the tube. So this is a resonant mode of this using a sound wave. If I go to about half this frequency, we might find one where just where there's an antinode in the middle. That would be the fundamental mode of this standing wave. There's the one I found first of all. This is the second harmonic, or the first harmonic if you like, the one above the fundamental, where there's a node in the middle and nodes on the outside and two antinodes here and here. Higher frequencies still can give us this one. Antinode, node, antinode, node, antinode, node. So there's two waves interfering with each other. Only certain frequencies will give you standing waves that fit exactly in the tube. So if I'm a bit off that, you can barely see a difference in the pattern. But if I hit exactly the right frequency, we get a fundamental mode. You can probably hear it in the sound as well. It's much louder when we're hitting a resonant mode. So nothing going on there, and there's another one, very clear, nodes and antinodes. So the Rubens tube, the flame is just to represent, not sure I can quite get that one. Anyway, the flame is there just to represent the areas where there is constructive and destructive interference within the sound wave. But I'm afraid you've missed your chance to see that in real life.